Hello class. Well, yesterday, if you remember, we worked with the idea of ratios. Today, we're going to look and see how to solve problems involving proportions. Okay, now, I gave you, once again today, you have a note sheet, but the definition for a proportion is on the board. It says any equation that states that two ratios are equal is called a proportion. A good way to remember that is if a fraction equals a fraction, then we have a proportion. Now, I'm on page 293 in your book, and if you notice, I put the words up there, means equals extremes. Has anybody heard that or seen that before? Okay, I thought that might be new. And if you look in your book, we've got this idea, okay? If I have a proportion, okay, let me use black. If I have the proportion A over B equals C over D, and remember a fraction equals a fraction, A and D, I'm going to mark them in green, A and D, okay, are considered the extremes, and B and C are considered the means. And so if you notice over here, when I have the idea of means equals extremes, we can just use the multiplication property of equality. And basically, as you've learned in 7th grade, to solve any proportion, the easiest way to get there is to cross multiply. All right? So the idea where means equals extremes, we'll use the multiplication property of equality. And so we're going to see as long as it's a fraction equals a fraction, the easiest way to simplify and solve that is cross multiply. Now, let's see how we can apply that in a couple different situations as we look at our next slide. So if you look here, if I'm looking at number 1 and I want you to solve, and we've got a fraction 3/8 equals another fraction 9 over 4k. Again, for me to solve to k, the easiest way to do that is to cross multiply. Means equals extremes. All right? So we're going to say 3 times 4 is 12k equals 9 times 8. Well, everybody knows 9 times 8 is 72. Now, what do I need to do to get 12 alone? Yes, to get k alone, I'm sorry, we're going to divide both sides by 12. And so we're going to get k equals, well, what's 72 divided by 12? And everybody says 6. And then you can go up there and check, and it does work. All right? Now, let's try a few of those on your worksheet. Everybody try a few on your worksheet. Okay, good job. Now, let's look at our second type of proportion. Let's look at number 2. Now, if you look at number 2, how does number 2 look a little bit different? Yes, we have binomials in the numerator. Okay, do you think we can still use means equals extremes? Good job. Yes, we can. As long as it's a fraction equals a fraction, we can still utilize that cross multiplying, that multiplication property of equality. So let's set that up and see how that looks like. We're going to multiply these two together. So I like to write it like this. Realize we're going to have some distributive property going on. Equals, and then we've got 7 times 3 minus n. So once again, what do we need to do first? Yeah, we need to take care of that distributive property. So we've got 4 times 2n is 8n. 4 times negative 9 is negative 36. And let's go to the other side. 7 times 3 is 21. And 7 times negative n is negative 7n. Now, what do we do? That's right. Letters on one side, numbers on the other. We're back to chapter 3. We're using those inverse operations. So I'm going to add 7n to this side. Okay? So I've got 15n minus 36 equals 21. And now we're going to add 36 to both sides. So we've got 15n equals, let's see, 57. Now, well, who's our floater? Who do we have to get rid of to get n alone? 15. But Mrs. Burton, it doesn't go in evenly. I know. Remember, if we're working with fractions, so if we get a fraction as our answer, it's okay. But my question to you, is that a fraction in lowest terms? You might need to pull out your divisibility rules. Hopefully you'd realize that the GCF there is 3, and so our final answer would be 19 over 5. Okay, so as long as we've got a fraction equals a fraction, then we're ready, we're good to solve. Now, let's see how we're going to implement this if we're doing a story problem. Okay, it says write and solve the story problem with a proportion. If 75 shares of a certain stock sell for $940, how much do 120 shares? Now, the big thing with these story problems is you've got to put the units in corresponding places. If I look at the first part of the sentence, okay, it says if 75 shares, so I'm going to put shares in the numerator, sells for $940, how much will 120 shares sell for? Well, since I put shares in the numerator in this fraction, I also have to put shares in the numerator of the other fraction. They have to be in corresponding places. Corresponding entries is what I call them. We're figuring out how much it costs, so that's where my x goes. And so now that I've got shares for both proportion, both ratios are in the numerator, money's in the denominator, now we can just cross multiply to answer. So means equals extremes. 75x equals, well, 120 times 940. Don't mess up on the basic math. We got to divide both sides by 75 to get x alone. And so x equals $1,504. So using the idea of proportions to solve story problems is very, very important. It's on the SAT and the ACT every year. So you'll have a lot of practice with that tonight for homework. Good job.